continuous array. For this question, it is asking us to find the maximum length of a subarray that has the equal number of 0 and 1s. So what does it mean? We are given an array of only 0 and 1s. And the question is asking us to find the longest subarray, continuous subarray. It contains the same number of 0 and 1s. So take a look at the example here. We have an array 0, 1, and 0. By looking at this subarray, so 0 and 1, it is a valid subarray because it contains 1, 0 and 1, 1, which are of the equal amount of 0 and 1s. So the length of the subarray is 2, right? So similarly, we look at this other subarray, it also contains the same number of 0 and 1s. Again, it has a length of 2. So the maximum length of such a subarray is 2 in this particular array, right? Okay, so intuitively for this question, right? So by given something like this, for example, like this is a input array, we sort of need to check each of the subarrays, like here and here and here, etc. Those subarrays, and try to find out if they have the same number of 1s and 0s. If they do, then we're gonna update the resulting lengths, right, until we find the maximum resulting length by iterating through all the possible combinations, and that will return our result. This requires a double for loop for each of the index. Like we have index I in here, we have index j in here, and then we're gonna find this subarray, right, and so on and so forth. So this will be n-square solution. That's not optimal. So like after thinking this away, try to optimize it. So for this type of question, we always like for the continuous subarray, right? We're always trying to think about how do we make it better by utilizing the prefix sum. Because prefix sum in the case that when we're iterating through all the elements of the array, what we'll get is we're gonna get a sum of all the elements. For example, the current index is here. We're gonna get this. The sum of this is going to be 4, right? We have a sum, and then by utilizing the prefix sum, if we minus the previously calculated prefix sum, we're gonna get, for example, in here, like the second index, we're gonna get the sum of these two elements, right? These two elements is sort of is like a subarray. We can get all the subarrays of this particular array by doing that. So now let's think about related to this problem. How do we utilize that? The interesting part for this is we have the element inside array is 1s or 0s, right? So 1 is useful because we are trying to calculate the perfect sum will be recording the information how many 1s are there. For example, this is 4. Means that the sum is 4 and then number of 1s are 4. But for 0s, the sum doesn't have useful information because no matter how many 0s are there, the sum will always be 0. So how do we get it better, right? So the intuitive thinking is we're going to try to map the original array to something that can be utilized, better utilizing the prefix sum. So by mapping 0s to negative 1s and the 1s remain the same, we are able to count our 0s and 1s better, right? So how do we do this? We can simply multiply the original array by 2 and then minus 1. So this will give us 1s will map to 1s and then 0 map to negative 1s like this, right? Now we can calculate the prefix sum. So the prefix sum for this above array is going to be like this. So 1, 2, 3, and 4, and then this is negative 1, so we minus 1 in there, so it becomes 3, and 3, 2, 1, and 0. So for this question, like this, you can see that this is a valid answer, which is the length of 2, and this is also a valid answer, which is the length of 4. And we are going to find this. This is going to be our maximum length of a subarray, right? Okay, so how do we do that? How do we utilize prefix sum in this case? All right, so this is very, very similar to what we have done in continuous subarray sum. Okay, so in this question, we are trying to, when we're iterating through a prefix sum, we're trying to find out what is the same value, what is the similar value for previous prefix sum. In this case, we can do the same thing because, for example, we have a 3 in here, and then we are trying to find out whether 3 appears before or not. So if it has appeared before, it means that by subtracting this and this, we resulting in a 0, right? What does it mean? So this means that we have 3 additional 1s, right? Because like by looking at the array, we have 4 1s and then we have a negative 1. We have 3 additional 1s compared to 0s, right? So similarly for here, it means the same thing. We have 3 additional 1s, but by minus these 2, we gonna calculate this is going to be the subarray, right? Without these three ones. So it's going to be a 0, which means the number of ones and the number of zeros are the same, right? As long as we have the prefix sum, we minus the previous prefix sum is 0, then we know that the subarray contains the same zeros and ones. So one very good thing about the result, like the subtraction is 0, is we can just look it up, right? We can look up the threes in here. So which is similar to what we have done in here in this question. We can save this value, previous values, in a set, and then we just look up in a set. That'll be like 01 time complexity, which is really ideal. So, but for this question, we also, besides the value we're gonna save, we also need to save the index, similar as the other question, because we want to calculate the maximum. So by finding threes in here, we also know that the index in here is 0, 1, 2, 3, 4, 5, right? 5. And then the index we saved in here, the first appearance of 3, is 2. So 5 minus 2, sorry, like this is 4. 4 minus 2 is going to be 2. So which means the subarray we have, which is 0, 1, and 0, is a length of 2. And by knowing this, we're going to update the our resulting value so that until we get the maximum length. So in here, like for example, like when we see a 1, we're going to find 1 in here, but then the length of this the subarray will be 6, which is greater than 2. So we're going to update the value, right, for the next iteration. Okay, now again, there is an initialization part of it too. So because like if we have a 0 in here, so we know that everything added together will be 0, right? So we are going to initialize the prefix sum to 0 for the first index, right? So which means like something like this, so that we can do things consistently. When we find a 0, we also see, okay, this is a 0 in here, and we're going to calculate the entire thing as our subarray. Okay, so let's take a look at the code. All right, so we initialize the result to 0, and we have a map, and the sum is initialized to 0. That's all standard. So here is what we have mentioned before. So we put the 0 to -1 because if there's no element, the prefix sum will be 0, right? And the index will be -1 because we're going to count what's the length of the subarray. Okay, now we can iterate through the entire subarray, entire array, and this is where we do the mapping. We're going to multiply by 2 and -1 so that it gives us a 1 and a -1 mapping. And we calculate the prefix sum. This is where we calculate the prefix sum. And then we are going to see whether we already see the sum before, like we did before. Okay, if the sum already appeared before, we are going to calculate the length of the subarray, because this indicates that we find a valid subarray. And here we're going to calculate the length of it. So if the length is greater than the result, our current length, then we override the current result. Otherwise, we're going to put it into the map. We see, for example, we see 3 for the first time. We're going to put it in there. And note that we will not put 3 again, right? Because if it contains 3, we're going to calculate it. The map only contains the first appearance of each of the prefix sum. And then finally, after all the iteration, we're going to return the maximum length about a valid subarray.